Hello friends, welcome back to our channel. In this video, we are going to understand what is TypeScript and why does everyone use it? Why do I see .mjs files sometimes? What is the difference between require and import? What does package.json actually contain? How do environment variables work in Node.js? These are the questions every developer asks when they start going deeper into Node.js. And in this video, we're going to answer all of them. By the end of this video, you will understand why TypeScript exists and how it is different from JavaScript, what .mjs and .cjs files actually mean, the difference between CommonJS and ES modules, what lives inside package.json, how environment variables work with process.env, and what Node.js Streams are and why they matter. Let's go. The problem with plain JavaScript. To understand TypeScript, you first need to understand the problem it solves. JavaScript is a dynamically typed language. That means you never declare what type a variable is. A variable can hold a number. Then the same variable can hold a string. Then an object. JavaScript does not care. In a small project, this is fine. In a team working on a large code base, this becomes a serious problem. Here is a real example. You write a function called calculate total. It takes price and quantity as parameters. Inside you write price into quantity. Now another developer uses your function. They call it like this. Calculate total of 100, 5. They passed the price as string, not a number. What does JavaScript do? It multiplies 100 by 5, string 100 by 5, and gives you 500. Wait, that looks right, but it only works by accident. If they had passed $100 instead, you get NaN. JavaScript did not warn you. Your IDE did not warn you. You will only find this bug in production. This is the core problem with JavaScript at scale. No type safety, bugs hide until runtime, no IDE autocomplete. Your editor cannot help you. Renaming a function, good luck finding every usage. Large teams on large code bases, chaos. Microsoft faced exactly this problem when building large internal tools. So in 2012, they created the solution. They called it TypeScript. What is TypeScript? TypeScript is JavaScript with a type system. That is the simplest way to say it. Here is what that means in practice. In JavaScript, you write this. Function calculate total of price, quantity, return price into quantity. No information about what price should be. No information about what quantity should be. In TypeScript, you wrote this. Function calculate total of price colon number comma quantity colon number. Okay. And you give with the colon number. Okay. Then return price into quantity. Okay. So now your editor knows what types are expected. If someone tries to pass a string, TypeScript shows an error immediately before you even run the code. Here is something important to understand. TypeScript is a superset of JavaScript. That means all valid JavaScript is valid TypeScript. You can take any .js file, rename it to .ts, and it is already TypeScript. But here is the critical point. TypeScript cannot run directly in Node.js. Node.js understands JavaScript, not TypeScript. So TypeScript must be compiled into JavaScript first. You write TypeScript, the TypeScript compiler called TSC converts it to JavaScript. Node.js runs the JavaScript. This sounds like extra work, but the benefits are enormous. Catch bugs before they reach production, get full IDE autocomplete, refactor safely across large code base, self-documenting code, types tell you what a function expects. That is why almost every serious Node.js project today uses TypeScript. Module systems. CommonJS versus ES modules. Now let's talk about something that confuses almost every Node.js developer. Module systems. Node.js has two completely different module systems. CommonJS, the original, ES modules, the modern standard. Both exist, both work, and they are not interchangeable. CommonJS. How Node.js worked from the beginning. Okay, so as shown on the screen, this is require and module.exports. This is what you will see in older Node.js projects. CommonJS loads modules synchronously. It was designed for server-side use from the start. ES modules, the modern JavaScript standard. Yeah, you can see the sample code on the screen. This is import and export. ES modules are the official JavaScript standard, supported by browsers and Node.js. ES modules load modules asynchronously. They were designed to work in both browsers and servers. Okay, you can see the key difference table. The ecosystem is moving towards ES modules, but CommonJS still dominates in existing projects. .mjs, .cjs, .ts file extensions explained. Now you understand module systems, so let us talk about file extensions, because this is where people get confused. .js, regular JavaScript file, whether this is a CommonJS or ES module, depends on your package.json. .mjs, M stands for module. This file is always an ES module, regardless of what package.json says. Import and export only, no require. .cjs, C stands for CommonJS. This file is always CommonJS, regardless of what package.json says. Require and module.exports only, no import. .ts, TypeScript file, gets compiled to .js by the TypeScript compiler. .tsx, TypeScript with JSX, React components. .d.ts, TypeScript, type declaration file, contains only type information, no runtime code. Now, how does Node.js decide whether a .js file is CommonJS or ES module? It checks your package.json. Okay, if type is module, all .js files are ES modules. If this field is missing or type equal to CommonJS, all .js files are CommonJS. This is why you sometimes see .mjs file. It forces ES module regardless of package.json. Package.json deep dive. Every Node.js project has a package.json. Most developers use maybe 20% of what it offers. Let me show you the important parts, the basics. Okay, name, suppose quality 360, version 1.0.0, description QA dashboard application, name, version, description. Version follows semantic versioning. We will come back to that. Scripts, one of the most important sections. Okay, as shown on the screen, you run these with npm run dev, npm run build, etc. Start is special. npm start works without run. This is where your entire project's workflow lives. Dependencies versus dev dependencies. Okay, so dependencies, packages your app needs to run in production. Dev dependencies, packages only needed during development. TypeScript, testing tools, linters all go in dev dependencies. When deploying to production, you run npm install -- production and dev dependencies are skipped. Semantic versioning, what? Cap, negation, and exact mean. Okay, yeah, you can see that on the screen. The caret is what you see most often. It means keep the major version, allow minor and patch updates. Engines tell npm what Node.js version you need. This prevents your app from being run on an incompatible Node.js version. Environment variables and the process object. Every Node.js application runs inside a process, and that process has access to information about the environment it is running in. This is the process object. The process object is available everywhere in Node.js. No import needed. It is global. Process.env, environment variables. Okay, as shown, environment variables are key value pairs set outside your code. In the operating system, in a Docker container, or in a .env file. This is how you store secrets in Node.js. Database passwords, API keys, JWT secrets. Never hardcode these in your source code. The .env file. You install a package called .env, npm install .env, then at the very top of your application, okay, require of .env.config. Okay, then .env reads the .env file and loads everything into process.env. Always add .env to your .gitignore file. Never commit your .env file to Git. Your passwords, API keys, and secrets should never be in version control. Okay. Other important process properties. Okay. Process.argv is especially useful for CLI tools. It gives you an array of all command line arguments passed when running your script. Node.js Streams, the last topic and one of the most powerful feature of Node.js. Here is the problem streams solve. Imagine you need to read a 10 GB log file and process each line. If you use the standard read file approach, Node.js loads the entire 10 GB into RAM. Your server runs out of memory. Your process crashes. Streams solve this by reading the file a little bit at a time. Think of it like water flowing through a pipe. You don't wait for the entire river to fill a bucket before using it. Water flows in, you process it, it flows out continuously without storing everything at once. The 4 types of streams in Node.js: readable, data flows out of it. A file you are reading, an HTTP request body. Writable, data flows into it. A file you are writing to, an HTTP response. Duplex, both readable and writable, a network socket. Transform, reads data, transforms it, writes it, a compression stream. A CSV parser, an encryption stream. The pipe operator, connecting streams. Okay, as shown on the screen, this reads bigfile.txt as a stream, compresses it chunk by chunk, and writes the compressed output to a new file, all without loading the entire file into memory. This is how Node.js serves large files efficiently. This is how Express handles request bodies. This is how video streaming works. Streams are everywhere in Node.js, even if you do not see them directly.